Hi guys, welcome back to my channel. This is Tejasvi Bodu. Today in this video we shall discuss about how to generate object code and object program for the Svce program. So here is our question. In this first we need to generate object code, then later object program. So first we shall try to calculate the location counter for each and every instruction. So this is our question and these are the values for a given opcode. So in this we are having 4 types of instruction, that is type 1, type 2, type 3 and type 4, where respective bytes has to be increased for a given operand. So in this we have our first location counter value as a 3000, that is first operand value has to be copied to the location counter value. Then here we have a clear and X. X is of register which is of type 2. So 2 bytes has to be increased. So 3000 plus 2 is 3002 as our next location counter value. And then later we have LDA as 0. As 0 is of immediate type which is of type 3, which means 3 bytes has to be increased, that is 3002 plus 3 is 3005. Then we have involvement of plus in our next instruction, which means it is of type 4. So 4 bytes has to be increased and we don't have any location counter value for the assembly directives, that is base. So 3005 plus 4 is of 3009 for our next instruction. Then we have a table comma x which is of index mode. So it is of type 3. So 3 bytes has to be increased. 3009 plus 3 is of 3000 C. Then we have our next instruction, that is count, which is of type 3 as well. So 3000 C plus 3 bytes is equals to 3000 F. Then STA total. So 300 F plus 3 is of 3012. Then R sub is also a third type, which means 3 bytes has to be increased, 3015. Then RESW1, reserved word 1, which means the value of 1 is equals to 3 bytes. So 3018 plus 3 is of 301B. Then we have a value called 2000 in our operand, which means 3 times of 2000, which is of 6000. And the hexadecimal value for a 6000 is 1770. So 301B plus 1770 will be getting the value as 178B. Then again we have the value 1 which is of 3 bytes. So 478B plus 3 is equals to 478E. So now let's start generating the object code for the first instruction. The mnemonic code for a clear X is B4 and this is a binary digits for B4, 8 bits binary digit. And clear X is of type 2 because there is an involvement of registers. So first 8 bits are opcode, then 4 bits for R1, then other 4 bits for R2. The mnemonic value of X is equivalent to 1. So the R1 is 0001. Hence 1011 is a B, then 0100 is a 4, then 1 and 0. So B410 is the first object code for the given instruction. Now our next instruction is LDA as 0 and the instruction format for a type 3, that is hash 0 is of type 3. So instruction format for a type 3 is of like this: 6 bits for a opcode and each bit for each flag bit, that is NIX BPE. Then if it is a type 3 then 12 bit displacement has to be taken. If it is of type 4 then address has to be taken. So as it is of type 3, 6-bit opcode and each flag bit and 12-bit displacement has to be taken. and the value for LDA is of 0 0. That is, they have given LDA is equals to 0 0, and this is a 8-bit code for a 0 0. So opcode, the first 6 bits has to be taken in a opcode. So 0 0 0 0 0 0, and it is of immediate addressing mode. So I is taken as 1, and all the flag bits has to be set to 0. As it is of type 3, the value of E is 0. So if we group 4 bits together, we will be getting the value as 0 1 0 0 0 0 as our object code. So our next instruction is plus LDB hash total, where plus is indicating that it is of type 4 instruction, and instruction format for a type 4 is of like this: 6 bit for opcode, and each bit for each flag bit, and address is to be taken for a type 4 instruction format. As there is a hash symbol, it is of immediate addressing mode, so I is taken as a 1 and rest are taken as 0. And as it is of type 4 instruction, the value of E is 1, and address for a given operand is total, that is 478B is our address. So 478B is our address in a instruction format. So we got this opcode value with a LDB value, and LDB value is given in a question, that is 68. So 8-bit format for a 68 is 011010000. So first 6 bits has to be taken in a opcode. So by grouping this 4 bits, we will be getting our object code as a 6910178B. And we don't have to calculate object code for the base, as it is of assembly directive. Then our next instruction is add table comma x. As there is a comma x, it is of index addressing mode, and it is of neither immediate nor indirect. It is a index addressing mode. So the values for NIX is taken as 111, and the value for opcode, that is add, the value for add is given as 18, that is 18 in our question. So this is of 8-bit format for 18. So we need to calculate displacement in order to tell that either it is a program counter base relative value or a base relative value. So program counter value lies between minus 2048 to 2047. So we need to calculate the value of PC, that is displacement is taken as 301B as a value 301B, that is table value is taken as a 301B minus our next instruction address, that is 300C. Then we will be getting the value as F. So that is taken in a displacement as well. Then as it is ranging from minus 2048 to 2047, it is a program counter value. So by grouping the values in a 4 bits, we will get our object code as a 1BA004. TIX count is our next instruction, which is of type 3, and the value for TIX is given in a question, that is 2C. So 8-bit representation for 2C is 00101100, where first 6 bits has to be taken in a opcode, and it is of neither indirect nor immediate. So the value for N and I is taken as 1, and as there is no comma x, index value, that is 0, is to be taken for a x. And in order to calculate either it is a base relative or a program counter relative value, we need to find the displacement. That is, displacement is equals to 3018 as the value for a count and minus our next instruction, that is 300f, and we will get the value as 9, and that has to be taken in a displacement as well. And as the 9 lies between this range, program counter value is taken as 1. So by grouping the 4 bits together, we will get our object code as a 2F2009. Next instruction is of JLT loop, where it is also third type instruction format, and instruction format for a third type is 6-bit object code and displacement is taken. So opcode for a JLT is 38, where it is been given in a question. So this is how the binary representation for a 38, and in order to find whether it is a base relative or a program counter, displacement has to be calculated, and 3009 has taken as the value of loop, that is address value for a loop is 3009. 3009 minus 3012, which is next instruction address, that is 3012 is taken. We will get the value as minus 9, and this is how the value, hexadecimal value, looks like, and it is a PC relative because the value of minus 9 lies between minus 2048 to 2047, and double F7 is copied in a displacement, and it is a third type, so E value is 0, and it is a program counter value. Then it is of neither indirect nor immediate, so both the value is taken as 1, and as there is no comma x, it is not an index addressing mode, so the value of x is taken as 0, and by grouping the 4 bits together we will get our object code as 3B2FF7. Instruction is STA total, which is also a third type instruction, so the same instruction format is followed, and it is of neither indirect nor immediate. The value for n and I is taken as a 1, and in order to calculate whether it is a base relative or a program counter relative, we need to find out the displacement value. So displacement is equals to 478b, that is total value 478b as a location counter, and 478b minus 3015, that is our next instruction address 3015, which is equals to 1776. So PC relative value should be lies between minus 2048 to 2047, but this value doesn't lie in this. If we convert it into a hexadecimal, this value won't be lying under this range. So the value for a P is taken as a 0, and the value for B is taken as a 1, and the displacement is taken as a 0. If we calculate again, 178b minus 178b is equals to 0, so displacement value is 0, and they have given STA value in a question, that is 0C, and this is our representation in a binary format, and first 6 digit has to be taken in a opcode. So if we group 4 bits together, we will get a object code as a 0F000. So our next instruction is RSUB, that is RSUB. The value of RSUB is given in a question, that is 4C, and this is a binary representation for a 4C. And the first 6 bit has to be taken in a opcode, that is 010011. it is of neither indirect nor immediate, so the value for n and I is taken as a 1, and as there is no comma x, the value of x is taken as a x, which indicate it is not a index addressing mode. And we won't be calculating b and p value as there is no value in our operands, and it is of type 3, so e value is taken as a e, and 0 is taken for a displacement as there is no values. So if we group 4 bits together, we will get our object code as 4F0000. Here we have already calculated the object code for a given program. With the help of this, we need to generate object program. In object program, we have a 3 section: header section, text section, and a end section, where the first column in a header section is always H, and other next 6 columns is taken as a name of a program, that is sum. So sum is taken in the first 3 columns, then next 3 columns is left blank. Then starting address is to be taken in our next 6 column, that is 3000. Then 1780 is our length of a program. It is calculated like 4780, which is of our last location counter, minus 3000 as our first address. So 4780 minus 3000 is equals to 1780. So that is taken in the header section. So our next section is text section, where uh, text section begins with a location counter 3000. So first that has to be noted, and later we shall calculate how we got the value 18. Now all the object code is noted line by line, that is like this. Then if we count all the bits, that is object code, we will get the value as a 48. 48 in the sense 2 column is taken as a 1 byte. So 48 is having 24 bytes. 24 bytes. So the value of hexadecimal for a 24 is 18. So that value is to be taken here. And end record, where our object code is ending. Our object code is ending in an address called 3000, that is end. So this is how the object program is generated. Thank you.